right, and welcome to the third and hopefully final installment of the constructive response for the Geometry Leap test. We are going to start with problem 36 in session 3, and 36 is one that, again, maybe shouldn't be considered constructive response. It is just a part A, part B, and they're pretty straightforward answers, but, you know, we'll treat it as though it were constructive response. Okay, so let's just go through A and B, highlight what we're looking for. We are looking for the maximum number of flower seeds, so we'll have to do some division, obviously, like we did in the last couple. And then we are looking at, we have so many seeds left over on part B. What is the diameter of the smallest circle that the landscaper can use to plant all the seeds? Okay, so 36. A landscaper is designing a display of flowers for an area in a public park. The flower seeds will be planted at points that lie on a circle that has a diameter of 8 feet. The point where any seed is planted must be 2 feet away from the seeds on either side of it. Okay, so they have to all be 2 feet apart. So let's sketch this out. We have a circle that's got a diameter of 8 feet. So this would be 4 foot and 4 foot. Can't draw, I apologize. There's my circle. And every 2 feet, we want to plant seeds. Or we want 2 feet in between. So maybe not every 2 feet because we might not be able to get it perfect, but we'll see what we can do. Okay, so what is the maximum number of seeds that can be planted using this design? Okay, and we're only, since it says that they lie on the circle and not in the circle, we can assume that that means the circumference or the outside of it. So circumference, you do have that formula on your formula sheet. Pi times diameter, or 2 pi times the radius. Let's use pi times diameter. Okay, my diameter is 8, so my circumference is 8 pi. Now, I want to so 8 times pi is the number of feet I have. So I want to do this every 2 feet. So we're going to divide that by 2 feet since we want 2 feet of space in between. 8 pi divided by 2 feet is, I don't know why I need a calculator, 4 pi. Now 4 pi, that's 4 times 3.14. Again, you can use the calculator, but that's going to be over 12. 12 point something. Just to be on the safe side, let's multiply by pi. 12.7. So I can plant 12.7 seeds. Can you planting 0.7 of a seed does not mean there's going to be 2 feet between. That doesn't really work. So the maximum number is 12 seeds. Yeah, or there are, we can get 12 2 foot, like 12 spots where there's at least 2 feet in between. So since there's that 0.7, we can add a little bit of space in between all of those spots. Okay. All right, part B. After planting the flower seeds, the landscaper has 20 seeds left over. We want to plant all of them in another circle. We want the seeds 2 feet apart. What is the diameter of the smallest circle the landscaper can use? So again, we want the same thing. We want them 2 feet apart. We have 20 seeds. So 20 is more than 12. So a good way to check to see if you're right or wrong is to see that your diameter is larger than 8. Okay, so again, our circumference is going to be pi times the diameter. And we want those 2 feet apart. So pi times the diameter divided by 2. Now this time we have that our circumference, we want 20 seeds in our circumference. So 20 equals pi times diameter divided by 2. We're going to multiply by 2 and then divide by pi to get the diameter by itself. So the diameter equals 2 times 20 divided by pi. So that is 40 divided by pi. And we get 12 point. That actually, I'm looking at that. That is 12.6, not 12.7. We get 12.7 here. So the diameter of the smallest circle would be 12.7 to 12.8 feet. It is to the nearest tenth of a foot. So let's say about 12.8 feet. All right. That is not too bad. And we can just go ahead and double check this. 12.8 times pi is 40. 40 divided by 2 is 20. That gives us 20 seeds. Okay. Yay! All right. That is the right side. All right, 37. So this is another quadratic, like on the last session. This is more algebra than geometry. Yes, there's area, but it's area of a square or area of a rectangle. Y'all know area of rectangle. Y'all don't need a formula for that. Y'all can handle that. Okay, so let's look. 37, a queen size, or actually, let's look at part A, part B. Part A, write an equation, define all variables. Okay, this is important. If it says define your variable and you don't do that, even if your equation is correct, if you don't define your variable, you're not getting any credit here. Part B, determine the dimensions of the king size and queen size mattresses. Show your work, circle your answer. Okay. All right, so now let's go back to the problem. Queen size mattress is 20 inches longer than it is wide. So let's draw that. So my queen size mattress, here's the width, here's the length, which is just 20 more inches. Let's go ahead and put W is the width. King size mattress is 16 inches wider than the queen, but has the same length. Okay, so here's king size. We added 16 to the width and 20 to the length. Okay. Now the area of the king size mattress is 1,280 square inches more than that of the queen. So the queen plus 1,280 equals the king. All right. Okay. All right, so let's think about this. Let's think about the easiest way to do this. Okay, so your queen mattress. So there's a lot. You could do a quadratic, but let's think about this as an easier way. We could find the area, W times W plus 20, and then find the area of this, and multiply these and add this to that side of the equation and simplify and all that good stuff. But we could do something a little bit simpler. Something we can do is, let's imagine the queen and the king have the same length. To get this extra 1280, I just need to add the extra width. So the area of the queen, and let's call that, well, let's not worry about that too much. To get this area is 1280. We have, this piece is that extra 16 inches, and this piece is that width plus 20. So 16 times the width plus 20, our length times our width, equals 1280. That's so much easier than what I did the first time. And that makes sense. This is our queen. This little bit of extra is our king. Makes sense. So really and truly, it's all about how you set up your problem and all about how you draw it. Don't be afraid to draw your stuff out. I don't care how bad of an artist you are. I draw it and I can't draw worth a darn. So it is what it is. Okie dokie. So we need to get W by itself. We need our width. And I did define my variable. W is width. Here's my formula. This is my equation. And actually, let's stop here because part A, write an equation, define all variables. Here's my equation. Here's my variable. It didn't even say show your work. It just said write an equation that can be used. And that can be used. Some other things that you could have done, some other possible answers. We could have done W times W plus 20 plus that extra 1280 would be equal to W plus 16 times W plus 20. And you could have simplified that. That would have been W squared plus 20W plus 1280 equals W squared plus 36W plus 16 times 20 is 320. And you could have worked with that. That I wouldn't want to. I'm just throwing that out there. No, absolutely not. No. This is 10 times easier than all this. This will eventually reduce down to this. But who wants to mess with that? Why would you mess with that? Let's look at part B. Part B, determine the dimensions of the king-sized and queen-sized mattress. So we're going to solve for width first. So 16 times W plus 20 equals 1280. So we are showing our work. Let's divide both sides by 16. You could have distributed by 16 as well, but then that'll be 16 times W, and then at the end you'll have to divide by 16. So let's just go ahead and divide by 16 now. 1280 divided by 16. W plus 20 equals 80. Subtract 20 from each side. W equals 60. Okay, so my width equals 60. Now let's go back to our picture. The queen size, the width was 60. The length was 60 plus 20, which is 80. Queen size is 60 by 80 inches. Okay. King size, width plus 16, so that is 60 plus 16, which is 76, by, has the same width, I'm sorry, same length, so by 80. So queen size mattress is 60 by 80, king size mattress is 76 by 80. All right, That's it. I like 37. That's because Miss Gallen's an algebra nerd rather than a geometry nerd. Okay, move stuff around. Here we go. 38. Oop, I have my phone in the way up here. 38. A billboard at ground level. So here's my billboard. At ground level. Actually, let's go through and highlight first, just so we know what we're doing. Create an equation that can be used to determine x. Discuss any assumptions that should be made concerning the equation. Use your equation to find the value of x. Show your work or explain your answer. Circle the equation and answer. Okay, so our points are going to come from creating the equation, discussing any assumptions, like, hey, we're going to assume that these triangles are similar, or hey, we're going to assume that these are right triangles, or hey, we're going to assume blah, 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 blah. Use the equation to find x. So we need to find x, but we have to do it with the equation. Show our work or explain the answer. So I'm looking at 3 to 4 points. 3 to 4 points on this. So yeah, all right, let's get started. So billboard has a support that's 26 feet long that extends from the top to the ground. So boom. There is a 5-foot tall post and is attached 4 feet away from the base support is. So let's look at this. We've got 2 triangles. Now, I would assume that these are 2 right triangles because these should be vertical and with the ground. So we're going to say assume the triangles are right triangles. And that the billboard is parallel to the post. The 2 right triangles are similar. Okay, so that's a lot of assumptions to make, but they're fairly valid. We should be able to assume that these are vertical. It wouldn't make much sense for this not to be vertical. Then it wouldn't lean this way if this is attached to the top. It would, unless this is a super long cable, that wouldn't, and then this would lean this way, that wouldn't really make sense. I mean, we could assume that it's leaning this way, but then it wouldn't really be a good billboard because it'd be hard to see. So we're going to assume that these are both parallel and that they are both perpendicular to the ground. It doesn't say that, but we should assume. I would assume that. Okay. Now these should, and even if they weren't perpendicular, these would be similar triangles because as long as these are parallel, this angle would be congruent to itself. These 2 angles would be congruent by corresponding angles, and this angle would be congruent by corresponding angles. So these are similar triangles by angle similarity. Okay, so now let's create our equation. We are trying to figure out how long this is. So if these are similar triangles, we have to figure out what sides we have in common. We have to figure out the scale factor or set up a proportion. I can't do that though I can't do that yet. Right now I have 4 and x. I have 5 and this unknown side. I have 26 and this unknown side. But this unknown side would be easy to find with Pythagorean theorem. So we're going to find the small hypotenuse by using Pythagorean theorem. So that would be 5 squared plus 4 squared, and we would take the square root of that. And we're going to keep this as simple as possible until we are at the very end. So the square root of 5 squared is 25, 4 squared is 16. That would be the square root of 41. So we're going to keep this in the radical till the very, very end. So this is square root 41. Now I can set up a proportion, which is going to be my equation. Okay, my equation should be, let's do the small triangle over the large triangle. So we have 41 over 20, or square root 41 over 26 is equal to 4 over x. We put our corresponding sides over each other. Okay, I'm going to circle my equation. We can use that to solve for x. Solving for x, we're going to cross multiply. And x times the square root of 41 will equal 4 times 25 is 100 times 26 should be 104. Because we're just one more 4. To get x by itself, we're going to divide by the square root of 41. X equals 104 divided by square root 41. We absolutely do not want a radical in the denominator. And also, since we're looking for distance in feet, let's not use the square root. Let's use decimals. So we're going to do 104 divided by square root 41, which was the last answer I had in my calculator. So I'm just going to do divided by answer. 16.2 feet. Okay, and this should make sense. 16.2, we want it to be larger than the 4, obviously. Should be smaller than the 26 because that's our hypotenuse. Okay, and let's look at, that would be a little over 4 times this. So let's look at square root 41 as a decimal. Oops. Okay, that would be 6 times, or 6.4, sorry, let's get the glare off there, 6.4 times 4 would be over 24, so that would be about a little more than 4 times as much. That looks to be proportional. All right, so it did say circle our answer. I boxed it. Oh my goodness. I don't think it matters, but this is geometry, and a circle and a square are 2 different things, so we'll be careful with that. All right. Okay, so our very last constructed response, number 39. Construction. Oh, it's a construction response. Ha ha ha. This one's fun because we get to write a lot. I'm going to do this in this pink one because I think it's a thinner pen. I don't want it to get super thick and yucky, so we'll just do that. Okay, number 39. Marcella drew each step of a construction of an angle bisector. Angle Z is given in step 1. Describe the instructions for steps 2 through 5 and enter your description. So we are just describing this. I am not sure if this is a 1-point or a 2-pointer. So what I'm going to do is I'm going to label each step, and we're going to talk about how this works. So I'm going to start with 2. Let me find a compass real quick. Okay. And all right, so I've got my compass. Not that you're going to actually need to write or use the compass on your test, but sometimes it's easier to kind of see what they did if you have the compass. All right, so step 1, we already have, they just gave us the angle. Step 2, I've got an arc. So if I look, this arc was drawn this way, which means my center should be over here. So if I put my compass on Z, I can see that arc. I can see how that arc was made. All right, so step 2, what we did was we placed the compass point, which would be our, like, we could also call it our center. On Z, and made an arc. Placed the compass point on on Z, made an arc. And then we have a point A and a point B. Those are the intersections of the angle and the arc. So we're going to label the intersections. As A and B. All right, so 3. Now we have this arc over here. Now if I place my compass point on Z, there is no way for me to get that arc. That doesn't make sense. You can kind of tell by that arc that this is centered out here somewhere. Okay, so let's look for points that I have on here. I could place my point on B, but that's going to make my arc go this way. If I place it on A, I can trace that arc. I can follow it. So my compass point is on A. So we're going to say place the center on A and make an arc. And notice we didn't put an arc way out here. We put the arc between these two lines. So on the interior of angle Z. Okay, step 4. Now we're trying to make an angle bisector. We don't want to have it closer to this side or to this side. So our arcs should have a congruent center. So we're going to say without adjusting the compass. Without adjusting the compass. Place the center on B and make a congruent arc. And when I say congruent, maybe congruent. I mean, it's an arc with a congruent radius. So let's not say congruent. Let's say make an arc that intersects the previous one. Okay, and then it should create an intersection. We're going to label the intersection C. And then step 5 to get from 4 to 5. The difference here, we have connected Z and C, so we are going to construct, that is a ray, so ray ZC, because Z is the endpoint. And that's the angle bisector. Okay. Whew, that's a long one, but we're done with it. let's move on to part B. Marcella wants to explain why this made an angle bisector. So why did it make an angle bisector? What she does is she connects she makes segment BC and segment AC. So if you look, we now have two triangles, and we're going to use similar triangles to create this proof. So using the figure, prove that ray Z bisects angle AZB. Be sure to justify each statement. So we're going to make a two-column proof. So we are at the end trying to prove that ray ZC bisects angle AZB. We also, in order to do that, in order to prove that this is an angle bisector, we're going to have to prove that this angle and this angle are congruent. In order for us to prove that these two angles are congruent, we're probably going to have to prove that these two triangles are congruent. So here's our map. I'm going to put to the side. We're going to prove that the triangles are congruent so that we can prove the angles are congruent so that we can prove angle bisector. Alright, so that's the plan. So we don't really have any givens. We're just going to start with what we have on our sheet or on our figure. Alright, so let's look at some sides. So let's look at ZB and ZA. How did we get ZB and ZA? Well, they were formed with the same arc. Okay, so C is the center of our arc or of our circle, and this arc formed AB. So we can say that ZB is congruent to ZA. Okay. Put this over here. Our statements are going to take up more room than our reasons are going to take up more room than our statements. So ZB is congruent to ZA, and that is because arc AB was formed with the compass centered at Z. So ZB and ZA are congruent radii. They're the radiuses of the same circle. All right, 2. Okay, let's look at BC and CA. So how did we get point C? Well, C was formed by our compass again. We went from A and we made an arc, and then we kept the same radius and made an arc. So we're going to say BC and CA were formed by a congruent radius on the compass. Okay, now we're going to get into some more traditional proof pieces. We have two sides. Now let's look at ZC. ZC is a side on both triangles. It will be congruent to itself. So ZC is congruent to ZC. That is an example of the reflexive property of congruence. Number 4, we have two congruent triangles. Okay, we proved that 3 sides were congruent. So now we can prove that our triangles are congruent. So triangle ZBC is congruent to triangle ZAC by side, side, side triangle congruence. Okay, 5. Now that we know that the triangles are congruent, we can say that BZC is congruent to angle AZC. So these two angles are congruent because they are the same angle on 2 different triangles. That's my favorite reason. CPCTC, which is corresponding parts of congruent triangles are congruent. And 6, last statement, because I would be tempted to leave here. So because these are congruent, that and this ray goes in between, cuts through angle Z, we have to say that ray ZC bisects, which this is what we were trying to prove, ray ZC bisects angle AZB. And that's because these two angles are congruent. That is the definition of an angle bisector. I will say this, I believe the proof was 2 points total. Look, if you are confident, look, please try the proof. But if you are nervous and worried, look, I know you could have gotten some of these points. Like, you could have said side, side, side triangle congruence even if you hadn't gotten some statements here. If you, and I know you know CPCTC. A lot of this you know. I would just look through some of your reasonings. If you still have the Unit 1 postulates and whatnot, are still on the course calendar if you need to take a look at those. Okay. Please try that proof, though, on the test. Like, try something. Set up your 2-column. Start with what you know. Fill in all the pieces you can. Try something. Do not leave it blank. You are too smart to leave that blank. You know more than you think you do. All right, so I am going to leave this here. Whew, another 40-minute video. That's it for the constructive response. I will, after school each day this week, if I can, I will be recording videos and of whatever problems we didn't get to go over in class. So that is one of my goals to be working on for y'all. If you have any questions, feel free to email me or ask me in class. I hope you guys have a great day. Good luck. You will be amazing. Bye.